All right, welcome to part 2 of the supplement video. I kept teaching, and for some reason the rest of it didn't get recorded. So I believe I was right here. So we were figuring out the expected value. I told you to kind of compute the probability times the amount that you would win in each situation. Put it in your calculator and you get 2650. You can see the work for it there on the middle line. Okay, we're going to skip the next example and we're going to go on to the raffle situation here at the bottom, and I've already filled it in, so I apologize for that, but I'll sort of explain what's going on here. Sometimes you won't be given given the probability explicitly, so you'll have this relative frequency table that won't be completely filled in, and you'll have to fill it in. So in this situation, total prize values are, or each prize value goes from 0, 5, 10, 20, and 50 for the last one here. The frequency, or the number of raffle tickets that have this value, are 200 for the 0, 50 for the 5, 25 for the 10, and so on. And what you've got to figure out is the probability. Well, probability is the number of favorable outcomes, or the number of outcomes of a given random variable, divided by the total number of outcomes. So for 0, there's 200 possible 200 raffle tickets that have a value of 0. And then if you take and you add up all of the frequencies, you get 300. So the probability of drawing a ticket with 0 is 200 over 300, or 2/3. So since that's the probability, what you can do is for each one, you can go through and write down the probability based on that. So you take 50 divided by the total, so 50 over 300, and 25 over 300, 20 over 300, 5 over 300. Now, you can turn these all into decimals or reduced fractions if you want, but your calculator doesn't really care. So, I've just left them, most of them, in unsimplified version here, and then in this unsimplified version, I can just plug them into the calculator. So that's what I did. I kind of wrote it out here, so you may want to write it out in your notes. But when you do enough of these, you'll see that you don't actually need to do the part where you write it all out. You can just type it into your calculator. So in my calculator, I've got it all written out here, or all typed in as just one line, and you hit enter, right? And then it will give you the value. So the expected value here, it does take more work to get because you have to figure out all the probabilities, but then the process is the same. Probability times the amount on the ticket, probability times the amount on the ticket, probability times the amount on the ticket, and so on down the line. You get $3.83. So that's the expected value of the game. So the application of this would be, well, if the ticket only costs you $1, then you should definitely play the game, right? Because $3.83, the expected value in the long run, is greater than the cost of the ticket. If the ticket was like $5, then you wouldn't want to play because the expected value in the long run is less than the value of the cost of the ticket. And that pretty much is it for the supplement section here, expected value and probability distributions.